Good morning. This is the first chapter triangles in geometry syllabus of GPSTR. So here they are mentioned meaning, type, properties, construction, area and perimeter, erosion formula, congruent and similar triangles, concurrent lines, centroid, incenter, circumcenter and orthocenter. First I will tell some basic concepts. Here basic concepts of geometry. Geometry is an English word. So we will use geometry. But it is from Greek word geometrian. So geo means earth. Geometrian means measurement. Here next is some definition. Point. A point is an exact location or a position. Next thing is line segment. Line segment, shortest distance between 2 points is called a line segment. So here AB 2 points. Here shortest distance between 2 points is called line segment. So line is a obtained by line segment extended on both sides. So line segment, if this is a line segment, so I will call it as AB and extend both sides. So that is called line. Line has no end points. Intersecting line. Two distinct lines meet at a point are called intersecting point. So parallel lines means two lines are parallel if they are said to be parallel, if they do not meet. Ray. Here ray is also portion of line. It is a portion of line at a point and going on one direction. So here one point is fixed. Next second end point is one end point is fixed in a ray. So curve. Curve is a line drawn done without lifting the pencil may be called a curve. Simple curve. A simple curve is a one that does not cross itself. So if 2 points, if you can draw any line between A, B, 2. But these two, suppose this is a simple curve. So it does not cross itself. Okay, this is AB. So suppose I will take this is not a simple curve because it is crossed at some point. So closed and open curves. Curve is said to be closed if ends are joined. If suppose ends are joined means like that. Sorry. If suppose these two are points, their ends are joined like this. Or like this. So that is called closed curve. Open curve means it is said to be open. Other than closed curve means 2 points are not joined. So this is an example of closed curve, but this is not example of closed curve. So this is example of open curve. Sorry, this is example of open curve. This is a closed curve. This is also closed curve. Polygon. Simple closed curve made up of line segment is called polygon. Polygon is help to define triangle and other polygons easily with the help of polygon. So in the first chapter they are asked meaning and types. So I will start with meaning. Triangles. Triangle is three-sided polygon. So already I told the definition of polygon. So triangles is based on sides. Based on sides we can divide the three types. One is scale and triangle, isosceles triangle, equivalence triangle. So scale and triangles means all sides are unequal. Isosceles means two sides are equal, and equilateral triangle is all sides are equal. All sides of triangles are equal. That triangle is called equilateral triangle. Triangles based on angles. On the basis of angles, we can also divide it into three types. That is, first one is right angle. One of the angle is 90 degree. That is called right angle. So second one is obtuse angle. One of the angle is greater than 90. One of the angle is greater than 90. That is called a obtuse angle. So last is acute angle. All the angles of triangles less than all the angles of triangles, angle A, angle B, angle C, all are less than 90 degree, exactly less than 90 degree, not equal. Okay, you should remember that. Second is property. Second, see, you can see here meaning. I will have covered meaning, type. Next I will move properties. So what are the properties of triangle? Sum of all the angles of triangle is 180 degree. So if you take any triangle, you sum up with 3 angles, you get a 180 degree. By using this, you can solve many problems. The sum of any 2 sides of a triangle is always greater than the third side. This is tells that if suppose this is a ABC, sorry, length of AB, I will take this length as A, this length as B, this length as C. So length of AB always greater than length of C. Length of BC is always greater than length A. AC is greater than third side B. So any 2 sides you can join that is greater than third side. So here say this is the similar meaning of that. So if any triangle, the angle opposite to the larger side is always greater than the angle opposite to the smaller side. So suppose this tells the meaning. Suppose I will take triangle ABC. So I will take this side as length A, this side length B, this side as length C. So here this is the greater side. So length of this side is more. Then we say this angle A is big. So like that, this is the meaning of that statement. So any side is greater side has greater angle. In triangle, sides are opposite to the larger angle is always then the sides opposite to the smaller angle. So this is the smaller, larger angle. If this is a small angle means this opposite sides is small side. Next, the difference of 2 sides of a triangle is always less than the third side. So suppose this is a triangle ABC. So I will take a length ABC. So here CB minus C minus B is always less than A. So this tells that if you take any difference of 2 sides, that will less than or equal to third side. Less than or equal to, not strictly less than, equal to third side. So this has completes the properties of triangle. Next, in the syllabus, next they are construction. I will discuss construction later. I will go through the directly area and perimeter. So also erosion formula. Erosion formulas, I will go through only formula. You should solve more example in 9th standard. So many examples are there. So you should solve that problems. So I will go through directly areas of and area and perimeter. So this is a triangle ABC. We generally know the perimeter is sum of the 3 sides, and perimeter is sum of the 3 sides, and area is half into base into height. This is we can learn by, everybody knows this formula, but I will divide this formula in this way, so that is easy for solving problems. Right angle triangle, if suppose they are given right angle triangle means we can draw perimeter as A plus 2B, and area is half into base into height, half into base is B here also, B into B. So B into B, we can draw half into B into B. We can half B square, we can easily write half B square. Equilateral. So here, suppose they gave a equilateral means all sides are equal. We can write perimeter easily 3A, 3 times A. So area is 3/4 side square. So if this is, we can derive this formula by drawing one perpendicular line. So that is not important for GPSTR. So you should remember the formula. root 3 by 4 side square. So scale and triangles. Scale and triangles means all sides are unequal. So all sides are unequal means we can apply Heron's formula. Heron's formula means perimeter is A plus B plus C. So Heron's formula is root of S times S minus A, S minus B, S minus C. S is the sum of the three types by 2. By using this, you can solve more problems. This is important for GPSTR. So isosceles. Isosceles means two sides are equal, one side is unequal. So here perimeter is 2A plus B and area is 1 by 4 times B times square root of 4A square minus B. So by this you can solve so many problems. That is helpful for GPSTR. Next we will move next concept, congruent and similar triangles. So I will cover congruent and similar triangles. Here congruent, two figures are congruent if they are the same shape and of the same size. If two figures similar means if my two figures similar means they are having same shape and size. If suppose two circles are similar, if suppose I will say two circles are similar, their side radius is equal means two circles are equal. If squares are equal means their sides are equal means that square is equal. So according to this, there are 5 theorems are there in 9th standard book. So SS is triple S rule, SAS, two sides, one including angles, three angles, two angles, two angles and one including side, two angles and excluded one side. So but one of you should remember this S double S, two sides, one excluded angle is not sufficient to tell that triangle is congruent. So you should remember this is does not a theorem to prove. So this is not enough. This is not guarantee that the triangle is congruent. RHS is also important. Given the length of hypotenuse of a triangle, right angle triangle, and the length of the one of the its leg. Next we will move similar figures. So what is difference between congruency and similar means? Congruency means both shape and size are same, but here same shape. If it has the same shape means that is similar. Next, here some theorems are there. These theorems are help to solve some problems. This is the Thales. First one is Thales theorem. That Thales theorem says if we draw one line parallel to one of the side, I will take one parallel line that is BC, EF. Okay, EF. I will take one parallel line that is BC. If their ratios AE by EB is equals to AF by EC. This is the Thales theorem. So if suppose AD by BD, if their ratios are proportional, then these two sides are parallel. So that is a converse of Thales theorem. This is also similar to Thales theorem. Two triangles are corresponding angles are equal. So their corresponding angles are equal, then their corresponding sides are in the same ratio. This is we can apply the angle A similar A congruence rule. We can prove this theorem easily. So this is also the triangle sides of one triangles are proportional to sides of other triangle. Then their corresponding angles are equal. Then as the triangle is congruence means ASA rule. If you apply ASA rule, this is also you can easily prove. So again, area of similar triangles. So area of similar triangles is the ratio of the area of two similar triangle is equal to the square of the area of third side. So this is the formula. Area of ABC is the ratios of two areas are equal to sides, corresponding side squares. So corresponding proportional side squares, AB by PQ whole square, BC by QR whole square, CA by RP whole square. In right triangle of the square of the hypotenuse is equals to sum of the squares of the other two sides. This is right angles theorem. This is the Pythagoras. Sorry, this is the Pythagoras theorem. So this according to this also you can solve so many problems. Next we will move. Next concept is concurrent lines. So concurrent lines means if three or more lines passing through a same point, then they are called concurrent lines. So here three lines are passed through one point, so this point is called concurrent point. Point of concurrence. A point through which concurrent line passes is called the point of concurrent. Next, they gave a in-center, centroid, it's one concept, in-center, circumcenter and orthocenter, four concepts. Okay, these four concepts, first one is centroid of triangle. Centroid of triangle, G is a center. I will take G is a center in the ratio. So this we can draw, this is a centroid, this is a centroid, it is a centroid. So this we can get a point G. This is divides in the ratio of 2:1. Here to be 2:1. Here also 2:1 ratio. It will divides. So I will write node AG is to GD, BG is to GC, CG is to G. This is centroid of triangle. Next is coordinates of G. So coordinates. These coordinates we can calculate. I will take x1, y1, x2, y2, x3, y3. In these three, you can easily calculate coordinate of G. Add the corresponding sides x1 plus x2 plus x3 divided by 3. y1 plus y2 plus y3 is divided by 3. Second one is in center. So angle bisector of, you should draw angle bisector. So this line is divides two equal angles. This line is two equal angles. This line divides two equal angles. At that one point it will meet. So this point to what it touches a circle, no? So this point to this circle, this point to this circle, this point to this circle, all these three lengths are same. So these three lengths are same means we can draw one circle with touching these 3 points. So we can get a one circle. So in center. So in this we can say that AB, this is AB by BC, AB by AC. These two sides ratio is proportional to BD by DC by Thales theorem. Similarly, we can take a BA by BC is equals to CE by EC. So like that you can tell the proportionality. And also here I is there means IX, IY can calculate easily by AX1. There if we know the sides A, B, C, so AX1 plus BX2 plus CX3 divided by A plus B plus C. IY is AY1 plus BY2 plus CY3 divided by A plus B plus C. So by these triangles. Orthocenter is we can take altitude of triangle. So one altitude, second, third, 3 altitude. That these 3 lines are orthogonal means makes an angle 90 degree. If you draw this angle, this line, it will make angle 90 degree. This line also made angle 90 degree. So this is the altitude. This is the orthocenter. So if this is the acute angle triangle means we get an orthocenter is in triangle. So if suppose if it is an right angle triangle means orthocenter is get here on the triangle. Third one is obtuse angle means outside the circle. This is in the circle in the triangle, on the triangle, outside the triangle. Last concept of this triangle chapter is circumcenter. So here we can draw perpendicular bisector of a triangle. So suppose they are given a triangle means you take more than half length and you cut, and more than half length of this cut and cut. If you cut and join these 3 points means we get a one, this point to this, join this point to these triangles, ends of this vertex of the triangles. So we get outside of one circle, outside, that is called circumcenter. In circumcenter, circle is outside, in center means circle is in center. So you should remember. So in right angle triangle, circumcenter is midpoint of the hypotenuse. Here we will get a midpoint. In center, we acute angle, you will get a circumcenter.